Alrighty. Hello everyone and welcome to another edition of Handmade Hero, the show where we code a complete game live on stream. Today is day 280, so if you are trying to follow along with the stream at home, you should start with day 279 source code, and you should get ready for some debugging, because what we are doing today is getting all of our changes working that we made as far as the way that entities are stored in our system. Because we're starting to make that be a more realistic part of the game now, a more real system that can actually handle what we need it to handle for our game. And so, due to this, we obviously need to think that stuff through and make it work a little bit more reasonably. So what we did at the end of yesterday's stream is we'd sort of gotten everything compiling and set up, but we haven't debugged anything. I guess I fixed a little bit of something because just I couldn't quite let it go. I fixed a few little things so it would run properly, but we're not actually running correctly. We're just not crashing. So we have a bunch of work to do to go verify that things are working right. And also somebody already posted on the forums, who I guess is following along every day, said we had a size of problem, which sounded pretty much like exactly what I would expect. For when we were packing stuff in, I believe it would have been size of source, like here. So you can look at the pack size here. When I was doing this, I was careless. We actually want the size of the thing we're packing is an entity, not the pointer. So this should technically look like this. Remember, we're not actually doing packing at the moment. All we're doing at the moment is we are sort of using the, we are just sort of block copying entities into world chunks when we sort of pack them. And the idea is that we'll just keep doing that for a little while. And then eventually, once we actually care, we'll come in here and do some work to sort of compact them down. Because eventually I think they'll be too large and you won't want to do block copies like that. So that's how that works. And so there was definitely a bug in there, and there was another one problem with stored index. Stored index, though, is kind of janky at the moment, and so stored index really doesn't want to be called stored index anymore. Stored index just wants to be called ID. There's no such thing as storage indexing or anything like that like there used to be. So really the name stored index itself is erroneous, and we haven't really fixed that yet. So rather than debug something that's not quite correct, we might as well do one more change here, since we're going to go through all the trouble of debugging it all. I kind of want to go through and say, well, from now on, we'll actually have a notion in here of the correct thing, which is instead of storage index, this is actually the entity ID, which is what we actually want, right? So then we'll come through here and we'll take a look at where all the stuff is being used, right? And we'll change storage index to an ID. So in store entity reference, this is what we want, meaning we'll be grabbing out of the ref what the ID actually is. Similarly, when we pass these things in here, that makes sense that we would be taking a look at those storage indexes, like so. When we record that for adding an entity, that is also what we will store there, is that ID. Same here. You know what, I should probably be doing that. I should probably be doing that not in this. I should do it in this window so we don't go behind my head. There needs to be a thing in 4Coder, since we're all using it to stream, that you can put a little thing that knows that there's a square down there or something. But anyway, all right. So storage index ID. Do we actually have any more, or is that it? Let's see. So get hash from ID. Let's actually change the name of that. Get hash from, I don't know where that actually is. There it is. All right. Get hash from, let's see, storage index ID. Yep. When we add entity, yeah, I guess that's still looking that up. We don't really need to pass that anymore when we do add entity. In fact, I might as well take care of that now. So when we do an add entity to the thing, really we can just sort of pass in the low here, because this will be the unpack operation in the future. And in fact, we could actually make this be a thing. Did we get rid of the non-spatial flag? I think I said I wanted to. So we could also get rid of that non-spatial flag entirely and just say that this isn't going to be a thing anymore either. So it's always going to do, you know, something like this where it checks the entity overlaps rectangle code, and it's going to do that add entity, something more like this. So this is actually an unpack operation, and so we might want to start calling that. I guess there's really no need to do it immediately, but that's where that's going to happen. Let me go ahead and get rid of these as well. Do we need to call make entity spatial? Do we ever call make entity spatial? I don't even know if we do or if we don't. Again, a lot of these things are going to kind of be changed now. So this is always going to complete like so. But again, a lot of this stuff, even that, is really not a necessary piece of code anymore. The get sim space p, we can sort of streamline that because it's only going to happen during the unpack. So no one should ever be calling that function anyway. It can be directly done in the pack unpack phase. So a lot of that stuff is going to get a lot cleaner, I think. All right, so let's take a look at add entity here. We know that we were passing sort of redundant information like the ID and the source, but we don't really need to do that because if we want the ID, we can just get it out of the source. Let's take a look at the rest of these. So storage index is going to be ID now here. Obviously, that's all fine. Checking for things like collisions is fine, right? These are all IDA, IDs, yeah, blah, 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 blah. All right, so non-spatial, if non-spatial is not set, property-based logic goes here, better hash function. So this is saying if non-spatial is not, if neither of them are set, then the result is that they can collide, I guess is what we're saying, which I guess is always going to be true now, right? And then, you know, you would need more logic here. But again, this is all stuff that I think we're probably going to start to clean up in a different way anyway. So let's take a look at those rules now. I think those would probably be in the world mode. So where is the pairwise collision rule? There it is. So this is just going to be IDA and IDB. There we go. So then we've got, let's see, non-spatial. We don't have to care about that. That goes away because it's gone now. We don't care about this at all. Let's see here. And then all of this can get unindented because everybody is now a spatial entity by default. There we go. And let's see. So we've got storage indexes. It's got ID here. And I guess these can all just be storage index ID. Yes, 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 yes. Go. There we go. Nothing to see here, just changing all of these to the correct word. Yep, yep, okay. So when we say make entity non-spatial, this is the sword. So the sword I wanted to get rid of, so the sword should not even be here anymore. And in fact, in the entity types, I don't really know where we were specifying that, probably in sim region still, because again, this code is kind of all old. But I don't even want the sword to be there, right? I don't want any of that. So let's see. We want the stops on collision is always going to be true, it would appear, because it's true for everyone but the sword, and there's no such thing as a sword anymore. So we'll get, oops. So we'll get rid of that. And we don't care about any of this even. In fact, all of this stuff is just nonsense. And most of it's going to go away. It was just from when we were sort of playing around and getting things working. If non-spatial is not set and entity flag movable, so we know non-spatial is never set, so really all we're checking here is whether it's movable, right? Any type of sword is not a thing. And off we go. I want to double check that when I was in the sim region stuff. I want to make sure I didn't mess that up when we did the result equals true code. So if set collides and collides, we assume it's true, then we look up to see whether we have a rule, and then if we do, we put can collide. So yeah, I think that's correct, right? It's like you always assume that the two things can collide if they are, you know, if they are set to be collidable, unless you have a rule that tells you otherwise. So that's fine. All right, so I think now we're a little bit closer to where we need to be. let's start running things and probably start stepping through things as well, like creation and stuff, to figure out what's going on. Now, you can see that we're in the red screen. What that means in general is that we don't actually have any heroes active, because if there's no heroes active, it'll sort of dump back to the main screen. So we kind of have to make sure that we have the rest of our stuff working properly. But hold on one second while we sort of figure that out. Now, let's see. Move entity. All of this stuff should be fine. And so I think I just need to go into Handmade world mode and start looking at the code where we create entities and pack entities and stuff like that, because that's presumably mostly where we care about this. So yeah, and so this code here, begin entity, where I put in the ID, we do a 0 struct here. So really, this needs to happen immediately after this, and these have to be bound together, because otherwise we would clear the ID value that we were just setting. So that also has to be set in order for stuff to work, obviously. Hey, we're getting a little closer. We're still not seeing anything, though. So now it at least believes that there are heroes in the game, so our stuff is getting created, but we still have this problem that we're not actually seeing anything. So we've got to work on that. This is obviously an assertion because we haven't talked about how we're going to delete entities yet, and so that assertion should stay in there because we're going to want to address that right away, basically. Like that, this assertion is something we need to, as soon as we get our bugs out, that's the first thing we want to implement, because right now we don't have the notion of deletion. And like I said, deletion is now going to just be in the stream out. You just don't stream those entities out. So if an entity gets like marked, will basically get marked deleted, and then when it gets time to stream it out, it won't get streamed out. And so that's what we want to do sort of immediately after we fix the bug we currently have, which is that we're not actually working, right? That we don't actually see these entities. So let's also just double check, because I don't actually know. I want to look at the sort of use debug camera, and I want to make sure that like we don't see anything nearby, like we're not just slightly wrong, right? And as far as I can tell, we're not, because it looks to me like you know, there's nothing in any of here. So we're pretty wrong right now. All right. So what I'm going to do here is just go and double check how we're doing our entity spatial stuff, and then I'm going to start stepping through the code to see like what we've actually created and what happens when we start a sim, so I can kind of get a feel for it. So what you can see here when I do the begin low entity and the end entity stuff, we take this world position P, and that's where the entity ostensibly is going to be. And when we do pack entity into world, we're calling into the world code here to do that. So when we call pack entity into world, you can see what's happening there. We get a world chunk out of the world, and it's wherever we were told that this thing was. And then we go to the world arena and say, if you can't, like we pass that in, so if you can't find one that already exists at this location, create the chunk. So that's how we know we'll always get a chunk back. And then when we get the chunk back, we call pack entity into chunk. We could also assert this here, because this has to always come back valid. Then when we go into pack it into the chunk, we take a look at what the pack size is. We've got it. We look to see if we can fit. If it can't fit, then we go ahead and make room for it. Otherwise, we assume that we can, and we go in here and pack the entity in at the end of the information. So I guess what I would say is right off the bat, I can see a pretty obvious problem here, which is that we're not actually storing the entity's position during this packing process, where you can kind of see that we don't record that location in any way, right? So we need some way of, we need somewhere central that actually occurs. So when I pass in a world position for pack entity into world, I'm assuming that what we should probably do is make sure that at is reflected in the actual entity information. So that's obviously a problem, right? So here's sim region, and you can see that we've got our P here, and we've got our chunk P, our chunk position here. So at least for right now, since we haven't really started working on this part of the code, which is how we're storing the entities in, you know, the actual data inside the entities, we should at least say that in here, when we do our pack entity code, we should update that piece of information. So we want to be able to say, like, okay, the entity that we're packing, its chunk p should probably be set to at, and its p value, which is its displacement, I guess that can just be ignored, because when this is unpacked, it's going to do the mapping to get it back out, right? And I assume that the way that happens, let's double check, that is in sim region, it's going to read that chunk p out again. So when we do the call to add entity right here, you can see get sim space p, and we pass that low. That's what I want to see. So what does get sim space p do at the moment? So it looks into that chunk p and gets it back out. So that should keep that piece of information stored properly at this point. But yeah, so again, we're still not there yet, not seeing anything. So let's go ahead and start stepping through. I want to see a few pieces of information just to give me an idea of where the bugs are at this point, which is that when I come into this code here, Handmade World Mode, I want to see what happens when we do that first unpack. So I want to restart before anything else has happened. I want to jump in here and see the very first time we go to begin sim. I want to see if we get any actual entities out, and if we do, what they are, right? So when we come through here, I'm going to set a breakpoint here to make sure we don't fall out of the loop, and then I'm going to set a breakpoint here to see if we get any. So you notice we didn't get anything. So what that means is that our initial pack and where we're looking, so our camera, for example, is not actually looking at where we put our entities or something similar, right? So one problem with that is, well, right now it's true that we wouldn't update the camera if we didn't call the sim code. I want to just make sure quickly, and this should have been happening before if it was a bug, so presumably it's not, but I just want to double check, because since we're coming back to this code after a long time, I want to make sure I kind of know what's going on. When we create the world, which actually should be up here somewhere, right? Where is it? There must be a place where we create the world. In order to create the world, you must make an apple pie from scratch. So here you go. You can see we do this world mode camera p equals new camera p, and here's where we set that up. So in theory, the camera should start off looking at those entities, in theory. So we probably should check to see what we're doing wrong in terms of why we're not seeing any of that. Because I don't know. So let's see. We have a bunch of stuff here where we do our sort of add code, and we generally always send those positions, which we use map into chunk space for that, and we use the sort of the basic stuff for that. When we're doing that, it seems like that should be done correctly, and when we do pack entity into world, I did double check that was doing it. So I want to step through to see if maybe there's something about the packing that isn't working the way that I would have thought. So when we do pack into, let's see down at the bottom here, pack entity into world, I'm gonna call the game here and I'm gonna restart it and see what actually happens. So let's see first of all what we think we're doing here. We're calling add standard room, and so we're kind of going through these abs tile x's and y's here, right? And it looks like those are, those should be relatively close to the 0, because they're pretty nearby. So when we call n entity, what we're passing for p is 0, 0, 0, which is a totally reasonable place to want to put something, and something that should be visible on the screen. So that's actually close, that's close to where the camera is going to be looking. So in theory, this should be okay. So when we come in here and we're asking for the 0, 0, 0 chunk, let's see what we actually get back. Looks all reasonable for the most part. And then we initialize that sort of that source entity that we're packing. We initialize its position. We jump into pack entity into chunk, and we look through here. We can see that it doesn't have any room for anything because there isn't even a block to begin with. And so what I'm going to do here is just step through here and say, okay, there are no free blocks, obviously, so we create a fake free block and put it on there so that we can use it. We grab it out, and then we clear it, right? So now we've got a block we can use. Here it is. And it's got sort of these residual things in here that we're going to get rid of eventually, but then it has entity data, which is what we actually care about. So we make sure that it has room, which by now it should, because we've basically ensured that it does. And then we've got this destination pointer, which is just going to be basically the beginning of the entity data. So we snap that so we can use it to pack, and then we advance by the amount of pack size. So we're basically like pushing something on there. Now, as you can see, we're going to cold set that right there, and we can double check now to make sure that our dest pointer actually contains a reasonable entity, which is, oh, it's a U8 by default, so I have to actually cast it to an entity. So let's go ahead and do that. Here is it casted to an entity. So you can see its ID is 1, which is what we would expect for the first entity. We can see that its location 0, 0, which we want. It is a floor element, which seems good. So all of this seems fine, right? That seems totally fine. No weirdness there. So then we pop out here. And this part, yeah, is just going to create more of these. And off we go. So as that happens, I don't think anything particularly odd's going on. But let's jump in just to one more here. And see if we can't watch it pack into something where there was already one, hopefully. Right, so we should be able to catch one that's getting packed into a chunk that existed. And I don't know, how long it'll take us to find that, but I'm just going to set a breakpoint and watch. So there you go. So in this case, we're now packing into one that actually already existed. You can see that it's had one entity packed into it, and now we're packing another entity into it. And so I want to go in and verify that that actually works. Not that that probably has all that much to do with our problem, but I just wanted to see. So here we are, we've got, we're going to go through and we're going to take a look at what the block looks like here. We can see that the entity data still has, a certain amount of size considered on it. We are going to grab the dest out, but what I'm going to do first before we do that is I'm going to cast this guy, this entity data, to an entity star so I can see what it looks like. And I want to verify that there are going to be two entities after this is done. So here's the two entities that I would expect to see. One is a valid entity, one is not yet a valid entity. And now when I do this pack, I should see it write directly into here and not touch anything in here. Just make sure the pointers are set properly. And it looks like that all worked exactly as we would expect. So far the packing looks pretty good. Not a lot of mystery there, so that seems reasonable. When we come through and do the rest of this stuff, we're just going to be creating a lot more entities in exactly the same way. And so let's take a look now at BeginSim and see why maybe that's having a problem. Now we watched, for example, an entity get packed into cell 000, or I should say chunk 000. So I'd like to see, do we ever try to iterate over 000? And if we do, why are we not seeing anything there, right? So I'm going to set a breakpoint here, and you can see our chunk values. So I'm going to go chunk X, Y, and Z. And I'm just going to let that loop on through, right? And in fact, I guess I can do it out here. I can wait till my Z value gets to 0. Then I can wait till my Y value gets to 0. And then I can wait till my X value gets to 0. Now, I know that this value, I watched it have an entity packed into it. So now I'm going to see what happens when I actually step in. Does that occur? So we call getWorldChunkInternal. Here we go. We do not find anything unusual about it. We did find a chunk. It matched the first time, so we didn't have to enter this loop at all. We now have a pointer to the chunk. We grab the result out of that. Here is that result. It does, aha. Well, that makes it easy. So, yeah, I don't even know if we need this value, but we are using it currently, and that's the problem. I don't know if you noticed that. I saw it, maybe I saw it a little bit before you did, if you were not eagle eye, or if Twitch's compression was not letting you see the screen well enough. But if you notice, what happens in here is in these worlds, we still had a residual value that's how many entities were in there, and we are using it right now. In the future, I don't think we will. We'll just probably stream. I don't know. Maybe we will, because maybe that'll be the easier way to tell when the stream is done. I don't know. We'll see. But at the moment, we are using it, which means that every time we pack an entity, we had better well actually increment the chunk's entity counter. Because if we don't, then we won't actually know how many are in there, and we'll always think there are none. So that's probably what was going on. Oops, and that's the block, not the chunk, sorry. And so that's probably why we weren't getting any hits in that main part of the code. Okay, so let's keep going now, and we'll see where we're at. Okay, so now we're actually back to good. We've actually got all the stuff going that we were having before. Although there are still some weirdnesses, like for example, we're not getting correct IDing of the head and the body there exactly. Like you can kind of see the body stopped tracking the head for some reason. So we've got a little more work to do, but we're getting closer to having completed this change in its entirety. So that's always good. And yeah, let me go ahead and exit out of this. And what the causes of that would be specifically is kind of odd. So, I say. So if we go to our sim region, the way that we were doing this, and it'll probably remain somewhat similar to this throughout the course of development, is we have this notion of an entity reference here, and you can kind of see what's going on with that, right? And what we want to do with the entity reference is we want to make sure that the entity reference is not getting cleared in some kind of unreasonable way. And I think what probably, in fact, I can almost guarantee I know what happens here. Those entity references are resolved now at the incorrect time. In fact, I think I even mentioned this when we went through it. If you look at get entity by ID, you can see that it does a get hash here. That process of unpacking the entity needs to wait until the very end. It needs to wait until the sim region is done unpacking all the entities and have put all the entities into their hash buckets. Otherwise, if it just gets unlucky and the head is before the body or the body is before the head, one of them will not be able to identify the other, right? And so we need to make sure that all the entities have gotten unpacked and their pointers added to the hash table before we start looking up anything in them. So I'm assuming that it's an add entity that's our problem here. You can see in add entity raw, we've got this code to call load entity reference, and load entity reference is really is almost certainly where our problem lies, right? You can kind of see what's happening here. We call get hash from ID right there. So we don't want that sort of thing to be happening at all. Furthermore, I'd like to take a quick look at this. We've got add entity and add entity raw, and I think now since we're focusing on the streaming being really the only way that you're allowed to put entities into and out of the sim, I think we can start to collapse these down a little bit. So if we take a look at add entity and add entity raw, the only difference between them is one of them you pass the ID and the other one you pass the actual entity pointer, right? And so I think we probably want to clean this up a little bit and collapse those down, since the cases we were handling before for this were simply not relevant anymore, or are simply not relevant anymore, I should say. So if you look when we were calling add entity, which is the only way we ever call it anymore, we do a entity overlaps rectangle of the total volume sim bounds whole situation, right? So I'm going to take a look here at add entity and just make sure we know where we call it. So you can see we're calling add entity, and I'm just curious, it seems to me that we're basically double counting. Oh wait, no, the updatable flag is just the thing that tells us whether it's in the inner area, so that's fine. So what I'm going to do here is I'm just going to take where we were calling add entity raw before. I'm going to take and I'm going to grab this function and I'm going to sort of stick it into this one here. So we don't need to call get hash from ID for this guy or any of that stuff because that's already been taken care of, right? That's something that we already know. We already know the entity's dest or whatever. Although no, I take it back. We do still need to do that. We always need to actually get that ID and fill it out, I suppose. So I'm going to put that in here, and I'm going to say we just do that up front. So here we get the ID. I'm sorry, we get the hash from the ID. and we make sure that it's actually something that we need to fill out, which is entry pointer equals 0. This is really an assertion now because you can never have two entities with the same ID come out. That would be like a major, major problem if that ever actually occurred. So that's really an assertion that it better never happen. We then come through and make sure that we can actually store this thing by checking it against the max count we're allowed to sim. And assuming that that actually works, then we can go in here and start to actually do other stuff to it. You can see in here, if the simp pointer there is valid, we'll go ahead and set that location. Now the sim, it seems to me that that should always be set, so I'm not actually sure, or it should either always be set or not set. In other words, like we only have one place that calls it now, and so I feel like that sim space thing, yeah, has already been called, and we're already getting a pointer to it. So I feel like this is kind of a bit redundant at this point, and we really don't need to worry about this case anymore. This should be working. Oops. This should be working this way all the time. There should never be a case where it's not going through that path. And so then we can come down here and say this part where we do, this sim space p. That's done. All right, so when we come up here, now we still have a bunch of work to do. Obviously, I'm just doing that very simple count there. Let me see here. Entity, this is dest entity, I guess. Let's go ahead and take a look at where entity is called. So this is dest entity, dest equals source, load entity reference, dest head is set, entity flag simming, source, add flags to simming. So we don't really want to be doing this to the source because the source is a fake thing now, and the simming thing is not a thing anymore. That's all just, we were using that for protection before, but we're not doing any of that anymore because you can't, if you were going to lock, you'd lock on the chunk level. You don't have to lock on a per entity level anymore, so that's all gone. This is just setting the dest stuff up correctly. There's setting the simp, the ID, the updatable stuff will be set by doing the check that it was doing before. And so now I think that's all much cleaner and doing the correct thing. Okay. And if we need to return the entity, I don't think we're returning entities anymore, right? So we would just have, this would just be a void because we're not actually doing any work on them outside after the decompression step. Okay. So now we should see exactly the same thing, but we should have the same bug. We have not touched the bug, we just cleaned up that code, right? So we should still be able to get the body to detach, like there we go. And so now we have to actually focus on fixing that problem of making sure that everyone decompresses first, and then we do a separate step. So again, it's not the most efficient thing, and maybe we need to think about how we might solve that, but at the moment, we'll just do the simplest possible thing at first and see to get us sort of to where we need to go, which is we need to have a connect entity pointers phase or something, right? And what we would do there is we'd pass the sim region, and what it will do is it'll just loop over, because remember, we've got the way the sim region works here is it just has some number of entities in it, right? So all we're going to do is we're going to say, okay, for every entity that was actually in this sim region, we're going to go through, we're going to grab that entity, and we want to remap the pointers in it now. So it would be after the fact. So this thing right here where we do load entity reference is actually going to be done external, like this. Okay? And so now, when, if we just ran it at this point, what we would expect to see, oops, missing a plus there. What we would expect to see is, well, two things. First of all, we would expect to not have to, I don't even know that load entity reference needs to be an actual thing anymore. But if it does, it certainly doesn't need the world mode for any particular purpose. So we can fix that. There we go. But what I was going to say is if we ran it now, we should see your head and the body should be completely, well, and of course, we can't even get past that because these things don't even have connections. So the head is pointing to nothing, or at least should be pointing to nothing. Entity head pointer. Well, that's actually, oh no, that's okay, right? Yeah, because it's just invalid. It's garbage data because this function is never getting called, right? So what we need to do now is after all of our stuff has been unpacked and we can now know that we can remap everything, then we can just call connect entity pointers and let it run through that list just one time to connect anything that needs to get connected via the hash table. So now we should be good to go. And in theory now, you would not be able to disconnect this little fellow anymore, right? All right. So that's good. So let's continue on this a little bit further. Let's just try to clean up some more of this. And just, again, we're just trying to get rid of some of those vestigial remains that we have before we start digging into the entity stuff a little bit more specifically and maybe creating some more stuff, right, that we can play with and so on and so forth. So at the moment, we've got rename simulated entity as a to-do. Well, that's been done, so that's great. And excuse me. Maybe I'll move this up to the top as well so people can always talk about entity if they would like to. There we go. So now if we have this entity flag, simming is no longer a flag, so we can delete it. And presumably nobody's looking for it, and that is actually true. So now we have our entity code. This entity code, I don't really know, can we move this entity code out into something more, into like the entity file, for example, as well. So I'm going to go ahead and do a little bit of cleanup there, just make that entity mode. I want to see, because we have a handmade entity.h, and I'm just curious to know if it would be possible for us to move this guy, to start moving some of these things out. Because we have all this stuff that's ostensibly entity related, and it's all in the sim thing. I just want to know, is that actually necessary? So I'm going to grab this, all of this, and I'm going to sort of grab that out. And I'm just going to put it in entity.h. So there it is. We'll see if that works. So let's see here. This is struct entity. There we go. Entity IDs. So it looks like, for some reason, the order of these, maybe there's a reason for it, but it looks like the order of these is a little bit backwards. So handmade entity, it comes after sim region. I'm not sure why that is. Yeah, that doesn't make any sense. All right. So we've got handmade entity now. And that's all set in here. And that now has all this code that we wanted to be isolated over in the entity file. So that's a little bit easier for us to keep track of, right? And we've also have our entity.cpp, which basically doesn't have anything in it, but we'll probably start to have a lot more stuff in it as we start to build out the logic for the game, and there'll just be tons of different entity code stuff that we want. Okay. So let's go into sim region here and take a look at what actually remains in sim region at this point. We can now delete this forward declaration, I believe. So you can kind of see how this all plays out. Nothing particularly unusual here, and the sort of code that we have in here is now more isolated to the sim, which is good. But we still, there's a fair bit of jankiness here, but it's starting to look a little bit more reasonable. We've got the simulation there, we've got the world storage, we've got the entities. We've broken it down into some pieces that seem relatively like they're systems that would work and grow, sort of isolated from each other in a certain sense. And so that's feeling relatively nice. Now, the next thing that I want to do is, I guess I would like to go back to sort of the physical way that we were, the way that we were creating things in terms of their their location and their sort of physicality, like the boxness of them and their movement. I think that's the next thing that we kind of need to start looking at. So what I would like to do is I'd like to go to handmade world mode and just start looking at exactly how we're creating these, like the worlds and so on. For example, I'm going to take out the up and down, the Z up and down kind of situation. I believe you can do that just by going like this. And then I'm going to let us create, 8 screens or something like that. And I want to just see if I can get us to a point where we're roughly like being able to explore like we would in a normal situation, because I believe that we had a bunch of problems here. So you can see what happened we already have a kind of weird problem there. And I remember we had this thing too, if you hop over the edge and stuff. We just have some weird stuff going on. So I think the next thing we have to do is just go fix the bugs that we have in that. Oh, no. You know what we need to do? That can wait till tomorrow. What we need to do is we have an assertion we can fix. This one right here. So how do we delete things? So what I'd like to do for deleting things, again, I think we already pretty much know how that's going to work. It's a very simple problem for us. What we can do is have an entity flag deleted. And if the entity flag deleted is set, then that just means, and let's see here. We go. We don't care about any of this because all this stuff is going to get reworked a little bit. Anyway, the entity flag deleted gets set, then we simply just don't stream that entity out, right? So that it just gets deleted as a consequence of the end of the sim, right? So then it's really easy to delete things too, but let's go ahead and implement that part first. So when we do our, I guess it's the pack entity to world here. So when we do this code, what we need to do is say, all right, as we go through these entities, what we want to do is say, okay, before you do anything else, if whatever this entity is, if its flags have been mentioned that it's deleted, then we aren't going to pack it, right? So basically, it cannot have the deleted flag set. If it's got it set, we will not pack it, and that way it just gets cleaned up automatically at that point in the process. What that means is it's trivial for us to have a delete entity, right? Delete entity is literally just a thing that on the entity, and we'll force you to pass the sim region just because we want to make you aware that, I mean, obviously you would have to have a sim region because otherwise there'd be no entity to begin with, but that's beside the point, I suppose. So what you want to do here is just say, all right, if it's supposed to get deleted, we just OR in the entity flag deleted, and it's gone. So now we should, oops, flag z. We should be able to re-implement so that assertion no longer is a problem. When we do that operation, we can say, I would like to delete this entity, and I'll pass whatever the hero is. Now, it's a little bit tricky because all we have at this point is the entity's ID. We don't actually have the entity itself. And so we need to, again, do that deferral to the actual simulation. This is just the controller code. And so what we want is conhero like exited or something, right? We want to set that to true. And then when we come through to actually process that, we can do the rest of it. So in here where we do the hero processing, you can kind of see in here we have the controller stuff. This is kind of janky code. We could probably clean some of this up as well. But point being, whatever we're doing here, blah, 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 at the very end, we can also just say, like, oh, hey, by the way, once we have that entity that we've loaded, we can delete it if this was a situation where the person exited. Okay? So all that's required to implement that properly is the ability to mark the fact that somebody asked for an exit. Again, very, very simple. And that's all we should actually have to do. So there's us exiting the game. And here's us re-entering the game. Exit the game. Re-enter the game. So now we're back to the bug that I was talking about before. We've got about 10 to 15 minutes left, I think, on the clock. So I'm not sure exactly what the best thing to work on is at the moment. Ground buffers, hey, guess what? They're not there anymore. But you know what we could do is we could just go look for what that bug is so that we'd have a head start tomorrow on reworking how some of that movement and world stuff is concerned. So like, why does that do what it just did, for example, is a good thing. And I believe where I had gotten to before is I was like, oh, right, the reason for that is in the entity structure, if you look, at the way that I did this, we have this notion of a bunch of these p-values here, right? So movement from, movement to. And really, all of those values are essentially erroneous once you've been packed. So position values have to get packed just like everything else. They have to be made relative to their chunk, right? Because when you pack and you unpack, you're doing this thing, you pack into a local coordinate system and you unpack back to a different local coordinate system. And so these movement values we need to actually process the same way that we would process the p-value, right? I guess I can start on that right away effectively. The first thing that I would like to point out is that this world position chunk p actually isn't a value that we need anymore, right? We can get rid, in fact, this entire concept, the concept here of this world position is now no longer even necessary at all. The only reason that we actually need it in any way is if we want to use it for during the construction phase. So I'm going to leave it for now, but technically it's not even necessary anymore. And here's why. So if I come in here, right, first of all, old chunks should be able to go away, right, because we're not using that anymore. And if I wanted to delete chunk p as well, I should be able to do that too. And here's why. So watch what happens when I compile. The chunk p, you can see that it's getting set in here, and the reason that it's getting set is because we have this world position at come through. But what does world position at, oops, that's no good. What does world position at have actually in it, right? Well, here's the world thing. It's got a chunk x, chunk y, chunk z, and an offset. So actually, the world chunk that I'm in already contains the chunk x, chunk y, and chunk z. So the only thing I actually need to store, right, is the offset. Because the other things are already in the world chunk that contains me. So I don't need the entity to remember. When the entity gets packed, it never needs to recall where in the world it was chunk-wise because it's in there, right? And so we can just ignore that part entirely. Now let's see what happens when we continue compiling. Okay, so get sim space p. Where is get sim space p called? Well, if you'll note, there's only one place it's called now, which is unpack time, which is exactly what we want. So all we have to do is make sure that when we're doing this operation, we just need to pass in what that basis chunk x, chunk y, chunk z is. That's all we really need. And furthermore, we don't even really need that. We just need the offset between that chunk and the chunk that the camera is in, right? We just need to know that offset. So really get sim space p is just an add. It's an add of an offset. So this is all garbage. It doesn't matter at all, and we can eliminate it. Remember when I said this was going to get really good? Well, this is the kind of stuff I was talking about. Basically, all those things that seemed like onerous things that were difficult to do, keeping the giant world, having things be offsets, having those things, all of that stuff just falls out once the architecture starts to get good. And that's how you know that you're on the right track, right? So in here, we can do exactly that, right? Let's take a look at what that code was doing. We can say, okay, what we need to know is we've got the sim region origin, and we've got this stored chunk p. We're trying to take a difference between those two, right? Well, what I can do instead is say, well, I know what the world chunk that I've got, I know what its world position is, so I could reconstruct that, right? I could say chunk position, I know exactly what that is, right? I could reconstruct that. I could reconstruct that because I know it's chunk x, chunk y, chunk z, okay? So then I can do this subtraction on the chunk itself. I can just say, well, tell me how far away the chunk, this will be like the chunk delta, right? Tell me how far away the chunk was. So we can take this origin of the camera, which we know, or of the sim region. We just go ahead in here and say, well, whatever that chunk position was, do the subtraction on that, please. Now, all of our positions, when we unpack them, do not need to go through anything particularly unusual. Instead, all they have to do is just add the offset. That's it, right? So instead of having to pass a sim space p here or any of this nonsense, what we can do instead is just pass a chunk delta, like so, right? and then get rid of this entirely. Although I suppose, since we want to be able to do the overlap check here, I should really continue to compute it just by doing low p plus chunk delta, right? Like so. But yeah, once I pass the chunk delta here, then basically everyone inside here can use the chunk delta to take their positions and turn them into real positions. Okay? So that means that now I can go to my entity, and all of the stuff that was in the entity struct that needs to get unpacked. So all of these v3s, right, like movement from and movement to, that we were having problems with before, which are not relative values, they're absolute values, and that was the problem. Those can just be adjusted just like everything else. So in here where we do dest simp or that nonsense, right, we can also just do dest movement from, right, chunk delta, chunk delta, chunk delta. So the decompression step now becomes very simple, and again, we'll coalesce this into a little bit cleaner style of thing in a minute here, but you get the idea, right? So if we do that, now this becomes very straightforward. What is the problem? Oh, that needs to be an address. There you go. And what is this problem? New camera chunk P. Yeah, let's get rid of that. And there we go. All right. So now what the problem we have is when we do our pack entity into world, that process is obviously a problem as well. The reason that's a problem is because all those position values are wrong now, right? All those position values in the entity are relative to the sim region. They need to be relative to the chunk. But, again, not particularly difficult, because once we have the chunk P, we can do the inverse chunk delta. So what we can do here is say, like, oh, okay, we know what the chunk P is, so what we can do is issue that subtraction call. This is not as clean, and it's because we do the chunks sort of out of order here. This, I think, will be we'll be able to make this much faster, much better code kind of going forward. But point being, if we want to here, we can actually make this code be relatively straightforward, which is to say that once we have the chunk delta, we can just do the inverse of the one we were doing. I could flip this track there, but I'm going to keep it the same so it's the same in both pieces of the code. And then what we can do is when we do all of our processing right, we can just go ahead and say, oh, right, add the chunk delta again to everybody who needs to have it. Right? That needs to not be there. There we go. So let's see. Let's see. Ooh. Didn't quite get that right yet. So, all right. Where are we at here on time? I got 5 minutes. So I'm going to go ahead and debug this guy, because then I think actually we might have fixed most of the movement problem anyway. So let's take a look here. We've got our chunk delta on the way in and the way out that we have to deal with. What is happening with the pack entity into world chunk P? This now needs to not do what it was doing before. Like this code needs to not do this, if that makes sense. So we got to get rid of that. And that is something that would probably now be done in... Where are you? World mode. That's something that wants to be done on end entity, right? To initialize this code. So there it is. Entity low equals P offset. Okay. So that needed to be fixed. I don't know if that's most of it though. Oh dear. What did I do? Pack entity into world. Why did that change? That should not have changed anything. This is what you get when you try to make quick changes at the end of a stream. What are you gonna do though? So entity low comes in. We're calling an entity, which everyone has to call. We call pack entity into world, but first we take the entity low's p and we take the world position that we're being passed, and we set the offset in there. Which all we were doing before is just oops. There we go. All we were doing before was just that piece of code as well. So why would that change have changed anything? Because right, that should not have done anything. Oh, right. Duh. It's because moving it out here means that that the sim region is not calling that code path anymore. And so I suppose that could obviously be it. All right. So if we come in here and if we assume that that's what it is, let's keep going here. That's kind of funny. So if we assume that that's what it is, if I take a look at what's going on here, we get the chunk p, which that's actually the entity's offset. So that's the problem, is I just wasn't paying close enough attention here. So what we actually need to do is figure out which chunk this is in minus any of the other values, right? So we want a world position that's, this is actually entity p, and we want chunk p to be entity p with the offset set to 0. Right? So that's actually what we want to have happen there. And where we were using chunk p before, we would use entity p for working with the camera, right? And again, we'll do another pass through this to clean it up a little bit nicer. Okay, so there we go. And so now we're a little bit better here. We can go off the screen okay, but we're not tracking the camera move, and I'm not sure exactly why. So let's double check that one, because we may be able to, again, like I said, just finish that up. So when we create the entity p here, what are we doing? We check to see, this is supposed to be entity p, that's why. There we go. Or maybe not entirely why. Room-based map into chunk space. And this is using the entity px. Yeah, so really, I guess if we want to do this, camera code should probably be rewritten, but if it's going to use the world p, this camera code needs to execute before we do any more of this, right? So this stuff actually has to happen down here, like so. All right. There we go. So not quite right yet. You can see it's a little bit janky there, so I don't think we want to call that done. But at least now we have the stable position packing and unpacking, so we're getting a little bit further there, which is good. But you can see it's kind of a little nasty. It's still not quite right. All right. Not sure what exactly that's doing. I need to slow it down so I can watch. There's like, it's a quick frame of the camera not being in the right place. I'm pretty much out of time though, so I'll go to the Q&A. That's, we're going to be working on this code soon anyway, so I'll just leave it there, and we'll do some more tomorrow. I'm going to go ahead and go to the questions and the answers. So if you have questions about where we're at this point, feel free to ask them now. Are there questions? Is there any real difference between if and def and if not defined? Not really. Not defined allows you to use it in more complicated expressions, but that's about it. Do you feel like we take steps backwards when we get into code we haven't been in a while, aka the problems with moving the screen? Not really. If anything, I feel like we're massively further than we were before, because this code was pretty awful before, and now it's getting quite nice. So it's usually more like as it has a chance to marinate, then when you can kind of come back to it, you're like, ah, this is how it'll all work, and it's nice. And that's pretty much exactly what's happening. Do you use a lot of header files? Well, I mean, we just break, since we compile everything in the same, we compile everything as one translation unit effectively. I mean, technically two, because we have a platform one, but basically we just choose to break things up into files based on what we want to see, like what we want to keep bucketed together for convenience. That's really it. And actually, so one thing that is true too regarding those pound defines is we don't actually need them. So we could get rid, like we could just get rid of those. They're only necessary if you were actually going to build out with multiple translation units. So technically, like if we just look at all of our H files, we wouldn't need, any of that anymore. That's just, it's not necessary. It can all go away, right? And yeah, it can all go away. So like handmade.h, let's get rid of that. And handmade world.h, get rid of that. Right? None of those things need to be there at all. Went through to handmade.h. Does not need to be there. There's some weird thing in 4Coder where, for some reason, page up doesn't go to the top. It stops at the first, like before the top or something. It's weird. I gotta go find out why that is. I don't really know why. There's some reason why it does that. I should write down it as a bug, but I keep forgetting. World mode.h, test asset builder.h. Oops. World mode.h. Let's see if there's any others. Shared.h. Type shader. Render group.h. Random.h. We should do a real random number generator sometime soon. That would be a good. I feel like that would be a good thing to do one of these streams, because we're going to need one of those at some point. So entity.h doesn't have one, and that's fine. Simregion.h doesn't have one. Math.h. Go. What else is there? Intrinsics.h. Oops. File formats. Debug UI. interface debug.h cutscene, almost done. Config audio, and the last one, yeah. So those were totally superfluous. They were just from the old Emacs thing that used to insert them, but they're really not necessary, so. Let's see, what else we got? Why not Pragma once? Because Pragma once was slower, so those pound ifs were faster than Pragma once. The reason for that is Pragma once actually still, for whatever reason, and do not ask me why, because it shouldn't have needed to be, well, okay. We'll say a few things. First of all, Visual Studio is like, it's an amazing how slow they managed to make a compiler. Especially because their older compilers used to be faster. They get slower and slower and slower, right? And so when, in 1999, I profiled build times very extensively back then. And I found that by far the fastest thing to do was redundant include guards. So the reason that I had those in there the way that I had them, where you do if, not defined, foo, pound define foo, end if, right? And here's the header. It's because then later in a CPP file, what you do is you say if not defined foo, pound include, foo.h, end if. That's what my includes used to look like when I used to use multi-file builds, right? And I timed those, and those were faster than Pragma once. So that's always what I did. And hilariously, after I left Rad Game Tools, and I think it was Dave Moore who took over Granny after Tom Forsyth took it over for a little while, and then Dave Moore took it over. He was like, do you still need to use the redundant include guards on the build? Can I get rid of those? And I was like, well, I don't know. You'd have to profile it. He profiled it again in I don't remember when it would have been, 2007, 8. And Pragma once was still slower. So, it's just like, what can I say? So, yeah, the fastest thing by far, though, is the way we build on Handmade Hero now, which is Unity build, right? It's all one translation unit. That's way faster than all that. So we don't have to worry about Pragma once or pound if or any of that stuff anymore. But if you are worrying about them, then the reason not to use Pragma once is if you haven't actually verified that Pragma once is faster on your compiler, then you may actually be slower than doing it by hand, which is hilarious. Because it probably shouldn't be, right? Let's see. Would you say the architecture of the entity system is based more on experience than on exploration? The opposite. I've never done an entity system similar to this one ever before in any way. It's completely different. I've also never heard of anyone doing an entity system this way. So it is both new for me and new, period, as far as I know. It's a completely different one. So it's 100% exploration, 0 experience at the moment. Do you have a plan for the components of the entities? Just use flags like you are now? Like I kind of explained before, we are not having the concept of components. All entities can have all things, always. That's the goal of the system anyways. As a codebase grows, new functions are created and others are no longer called anywhere. Are there any good ways that you recommend for finding out which functions of code are never used? Other than just when you spot them, not really, no. I mean, technically, that's probably something that would be really easy. What? So you should be able to turn on a linker warning of the form, like comdat blah was not called and has been removed or something. So if you set it to compile like individual functions to individual comdats and like, and ask it to give that warning, you could probably get Visual Studio's linker to tell you what, when you turn on full optimizations, right, opt-ref and all that stuff, you could probably get it to tell you, here are all of the functions I threw out because nobody called them. Because it will do that. It'll do the call graph analysis and go, I can never get to this thing, so get rid of it. So that might be one way if you're looking for a way to do that. I don't know why you would bother necessarily, because if you don't know about it and you haven't, it's not like it's taking any of your time, right? And if you stumble upon something, you're like, hey, I wonder if I need to keep maintaining this. Does anyone call it? Just delete it and compile. And if it compiles, then the answer was no, right? Duroid, is there any way to run the game entirely and find out what parts of your code isn't being used to get rid of? There is and there isn't. Obviously, you can do what's called coverage profiling, and coverage profiling, different profilers have it. Depends on, you know, it's a code profiling operation, so you need a profiler for it. And basically, what that'll do is it'll tell you what code paths have been hit and which code paths haven't. But the problem with that is in a game, you don't know if that's because the player who did that test run just never got to the part of the game or did the thing that would cause that code to run. So while coverage testing can be very useful for letting you know what parts of your code haven't been run, what it really just tells you is these haven't been run. It doesn't tell you they could never be run. And so you kind of need to augment that with some thinking of your own and designing, you know, how you're going to play test to make sure you actually find out if those things ever get called. You can't just assume that because they didn't get called in a particular run-through that they're never called, because that's probably not true. So let's see. Someone said the Dynamite Jack entity system is similar but without the compression. Well, the compression is kind of the important part. It's like the thing that actually makes the system what it is, right? Obviously, there's been plenty of games before that just have one entity type. That's not unusual. The unusual part is making an entity type that has so much stuff in it that you couldn't actually store it that way, but you compress it down dynamically as you go, right? Have you checked lock recently? Yeah, we did the other day. $15,000? How is your arm now? Any chance of a streamathon? I'm not super in the mood for a streamathon, but my arm is doing okay. Dude in basement. C-time needs clock built in. Well, it can't really do that, right? Because it doesn't know what you're compiling. So at Mali, I actually am pretty close to having that. Probably the next rev of our tool chain will have that. because everything will be going through the metaprogramming system instead of only some things going through the metaprogramming system, and then it will keep both timings and clock because it knows all the code at that point. But it hasn't gotten there yet. So eventually we'll have that at Mali for sure. But CTime can never really have that because it doesn't require you to give it that information in any way. And it would actually be problematic for it to gather it because the work it's doing to gather it would actually increase your build time because it has to read it all. Now, probably not very, very much, but... Jerun says, recode coverage. When Farbrush was trying to cut down size of K. Krieger, they wrote a quick code coverage tool called Lector, and because someone didn't use a certain key in the menu, the code to handle it was left out of the release version. Yeah, that's exactly the problem, right? And it's a really difficult problem to solve because there's two types of unused code. There's the kind of code that can never be reached, and that kind of code is relatively easy for or I should say, there's the kind of code that mechanically could never be reached. Nobody ever takes its address. Ergo, you can never get to that piece of code, barring some kind of a bug or a hack, right? And that kind of code is easy to remove, and the linker can remove it for you. The other kind of code is code that could technically be reached potentially. Like someone does have the address of it, and it would be compiled into the program, but it turns out that the state of the program as it is can never really get set in a way that you'll reach that code. And the problem is that's impossible to tell, right? I would imagine that a computer science student could probably prove that that's analogous to the halting problem. Like, if you could write something that would tell you whether a particular line of code could ever be reached, then presumably you could solve the halting problem because I just ask you, hey, can the final line of this program ever be reached? And now I can solve the halting problem because you will have told me whether the thing will ever exit, right? So I believe it is a literally unsolvable computer science problem to tell you whether a particular piece of code can ever be reached. And so it's a very difficult problem, and especially like in the situation that, like for example, that Farbrush was in that case, it's like, especially if you're in a rush like that, like they were trying to get finished for a competition or whatever, and that's similar in games, right? Oftentimes you may have some tight deadlines or something. Trying to figure out how you can put in some kind of instrumentation to tell you all of the code that might be hit is really pretty difficult because you just don't know how to make sure that your testing of that hits all of the right things that could happen, right? You don't know what things are sort of unusual. Now, one of the things that you can do, obviously, is when you are programming the game, you can try to avoid the kinds of code that happens extraordinarily rarely. You can try to make sure that most things go through the same code path, so at least the code path has some coverage. Now, that doesn't necessarily help have the code path be tested within the bounds that you're expecting, because values can be drastically bigger or smaller, and maybe you never hit those cases or something that go through. So that part is a little bit of an issue for sure. But you see what I mean just in terms of it sort of being something that you can kind of design for a little bit when you're programming, but on the whole, it's not just a hard problem, it's like an unsolvable problem. So you're always dealing with some kind of approximate way that you're planning to attack it, and there's not some magic bullet where you can just be like, I just run it through this program that tells me all the places, all the code that is live and all the code that's dead. That's not possible. And I think, like I said, I strongly suspect that a computer science persons would be able to tell you that's kind of a halting problem. It's analogous to a halting problem, and you can't actually solve it in the grand scheme of things. Like I said, linkers will do the basic version of it, and compilers do dead code elimination all the time. So anything that's reasonably easy to conclude that you can't get to, that's already being removed for you. But things that are more subtly not possible to get to, like, can this menu item ever be reached? Like, can you even pop up this menu? Who knows, right? Like, that's such a complicated thing to figure out. Well, I don't know, like, how big was the screen, and maybe it's something that's so far off the screen it's almost never possible to click on, but if the user has a big enough monitor, then it turns out you can get to this weird button that we forgot about, and you can actually get to it, right? All those sorts of things are weird. And then you also have the question of, should you have been able to get to it? Was it a mistake that was left in there? So even when you're answering the question correctly, you could still be wrong in that, well, it should have been removed because it's not supposed to be there, blah, 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 right? So. All right, looks like there's really not any more cues that need A-ing, so I'm going to wrap it up. All right, thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org. It comes with the source code so that you can follow along. There's also a forum site if you want to ask questions, a Patreon page if you want to support the video series, a schedule bot that lets you know when the episodes air, or I should say when the stream is live, and an episode guide if you want to catch up on old streams where if there's something that we've already covered that you want to go and figure out how it works, you can go watch that as well. That's about it. I will be back here tomorrow, 5 p.m. Pacific Daylight Time, when we will go over our camera code and kind of figure out how we want that to work. I feel like we're going to want to do interpolating cameras because now that I'm doing room locked, we'll probably want to do like a thing that kind of like slides quickly from room to room. So we'll probably get that going tomorrow. That's about it. Hope all of you have fun programming, and I will see you on the internet. Take it easy, everyone.